Hello everyone, my name is Kevin Ventimiglia, and I'll be presenting on behalf of Team CPMC for our final deliverable. Basically, in this final deliverable, you'll see a little bit about what it needs to be about our problem statement, or about the category partition method, the technologies and system structure, implementation, demonstration, and also the challenges we faced. The remainder of what needs to be submitted will be done by Michelle, and that will be in a separate video. So let's begin, starting with our problem statement recap. The main goal of this project is to implement an API that uses the category partition method. The API must accept an input file and deliver an output file with all of the test cases. The output file must show the expected test results in the equivalence classes for the given parameters. You'll see a little bit later on when we do the demonstration that unfortunately we weren't able to get the expected test results, but we were able to get the total amount of combinations done. And then this next slide will explain a little bit about the category partition method. So what is the category partition method? It's a black box testing method that allows the tester to generate equivalence classes for each parameter. So example, the integer parameter can have equivalence classes negative, positive, maximum, minimum, 0, and so on. The purpose is to eliminate testing every number of the same type or in the same equivalence class. So an example would be the numbers 7 and 8. So if I had a method that was needed to test, different parameters or integers, I would only need to test one of these numbers. I would not need to test both 7 and 8. The reasoning behind this is that both the numbers are positive integers, therefore they provide the same functionality under test. So if I was to add a number, if I was to add 7, it would almost be like it would almost be the same as adding 8, right? Because they would both provide the same functionality. So that is what's useful about the category partition method, is that it helps eliminate the need to test numbers of the same type. So going back to the method where I have to add an integer, I would only need to test one integer that's positive. I would not need to test 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on up to positive infinity, because that would take too long. What I can do is I can just test one number and see the result based off of that. Moving on to our technologies and system structure, the framework we use was Spring, and the system architecture is designed based on Spring MVC. The Spring MVC framework provides a model view controller architecture and reads components that can be used to develop flexible and loosely coupled web applications. The key part about the Spring MVC is in that little last part right there, loosely coupled web applications. Loosely coupled is one of the requirements of building a REST API. And so it's important that we have that inside of our API, because it's one of the building blocks that define what a REST API is actually. Moving on to what the MVC stands for. So M stands for model, and the model encapsulates the application data and consists of plain old Java objects. The view, or the V, stands for view, and the view renders the model data and generates HTML output. C stands for controller, and the controller processes user requests and builds appropriate model data and passes it builds the appropriate model and passes the model data to the view for rendering. So the way it works is, you can see in this little picture on the right here, an HTTP request will be sent to the dispatcher servlet, and then the first step is that the dispatcher servlet will consult with the handler mapping to call the appropriate controller. And then in step 2, the controller takes the request and calls the appropriate service methods based on the used get or post method. And step 3, the service method will set the model data on business, or based on the business logic, and return the view name to the dispatcher servlet. Also in step 3, the dispatcher servlet will take help from the view resolver to pick up the defined view for the request. And then finally, once the view is finalized, the dispatcher servlet passes the model data to the view, which is rendered on the browser. So I'll go through an example real quick, showing just kind of an idea. So if I go to my browser, and let me just close this. So if I go to my browser, and this is the HTTP request right here. So if I were to hit enter, it would send an HTTP request to my API with a get method, right? And a get mapping method is a method that's going to return the resource to me. So in this case, it'll be my API. So as you can see, the first thing was to send the HTTP request, right? And luckily for us, when we import using Spring, we can skip all the parts going through the dispatcher servlet and the view resolver. We don't really have to worry about that, more so of the model and the controller and the view. But what's going to happen is HTTP request will be sent in the back end with Spring. The dispatcher servlet will use the handler mappings to decide where to go. So initially, the API will bring you to this mapping method, right? And pretty much what this will do is it'll set a model and it'll add data to that model based on the logic inside of our class. But one thing that it does is before it returns the view form is it goes into, or it calls this method called storage service.loadAll. And this is part of a different service inside of our file system storage service class. As you can see in this class, it's annotated by service. So what the controller will do is once that method is called, it'll search for services, and then inside the service, it will search for that method. So what that method is doing is it just returns, excuse me, I was in the wrong one. It just used to load all the files stored in the upload directory. Essentially, it just streams the path of the file inside of our directory. And then what it's going to do from there is the view resolver is going to return the name of the HTTP form. And once again, we don't really have to worry about that. All we have to do is just return the name of our upload form or our HTML form, which is a upload form. I can show you here. You can see the HTML file is called upload form. So once it returns that, the dispatcher servlet in the background will pass the model data into the view, and the view is rendered into the browser. So essentially, everything is happening at one time. The model is being populated using this method called serve file. Essentially, what the serve file do is it's building resources based on the path of the file in our upload directory. So yeah, everything is just happening so fast with this, but hopefully you were able to follow along. Yeah, so let's just go ahead and move backwards to this. So if you have any more questions about this, there's so many resources online, but our technology is basically following this pattern right here. So moving on to what was implemented by who. So the first thing we had to do was parse the file, and the people that worked on that was myself, Puen, and Michelle. The next thing we had to do was the combination algorithm, which I worked on. That was all me. The handler error messages, myself and Puen did that, just because we had certain errors that were going to be thrown, and we had to make sure we handled those properly. The HTML code was done by Constance and Michelle. Michelle mainly added to it, and then Constance did majority of the HTML stuff. And then writing to the text file, Michelle was the main person for that, and I helped add a little bit of formatting to the text file output. So let's go ahead and move on to the demonstration. So I will demonstrate use here. So if I was to load the page, so let me just close that. So the first thing we do is our website is called category-partition.herokuapp.com. So you can type that into your browser, and the first thing it's going to do is it's going to what's it called? It's going to load this page, right? So when you load this page, let me full screen it for you. I'm sorry about that. So when you load this page, you have 3 columns here, or what looks like columns. On the left is basically our problem statement. So if the user is curious about what the page is supposed to be doing, they can read this and understand a little bit about what's going on. If there's still any confusion about how to actually use the page, the user can click on this link, which will bring us to a user guide. And the user guide is inside of our repository. Basically what it does is, at first, it explains a little bit about the API and what it's supposed to be doing, a little bit more iteration about the first part up here, right? And then it goes into a step-by-step walkthrough of how to actually use the API. So let's just follow this by hand. So the first step is there's a link provided on the web page that brings you to a sample JSON file and how your file should be formatted. Use this to help you format your file properly. So if I go back, I can locate the link, which is called example JSON file. Essentially, what we want is the user to have a properly formatted JSON file in order to prevent any errors from occurring while the user is trying to upload a file. So I can click on this link, And what it'll do is it'll bring you to our repository where an example JSON file is listed, and the user can view this file and format their file based on what they see here. The key thing is that the user includes the input parameters keyword and equivalence class keywords, because this is what our parse method uses to parse the file. So we provide this for the user so they can have a reference as to how to parse their file to help prevent any errors when trying to receive their output file in the future. So let me close this. Go back to our text. Once you have a JSON file ready to be uploaded, simply click the Choose File button and select your file. So if you go back, I can go to Choose File. Let me go to right here. We're going to use execution queue on save. This is a JSON file. I'm going to open it, and let's go back to our guide. Make sure you choose a JSON file, or else the API will not accept it and return an error message instead. So let me demonstrate that error first. So if I was to choose a file that's not a JSON file, let me just go to my documents and find something. Combination algorithm. Let me just use this one right here. So if I was to do coding .docx, you can see it's not a .json file. So if I upload it, you can see you get this error message here: failed to store non-JSON file. We want to prevent that, so that's why we provided the example JSON file here. And we also provide the note here as well that the file must be .json. So let me go back and let me just choose a JSON file. The next step said to, sorry about that. The next step said to click the upload button. You will now be able to see 2 download links. So let's do that. As you can see here, we click upload and we get the message: you successfully uploaded execution queue on save.json and received execution queue on save-combos.txt. So the next step in this guide says to, or it just describes what each file is. So the .txt file is a file you received with the generated test cases. The file with the .json extension is the same file you just uploaded. Unfortunately, we haven't figured out a way to eliminate storing the JSON file, so we have to keep it as part of the return as well. But the one we care about is the .txt file. So let's read the next step. In order to download the file with your generated test cases, simply click on the proper link and it notes that the file with the .txt extension, and open the file in your text editor of your choice. So let me go ahead and click on the link. It should be the one with the .txt, so I'll click on it. And as you can see, the download link pops up, or the download process. I can click it, I can open it, and now I have all of my test cases here. So basically, that's like the main functionality of our API. A user can upload multiple of these or multiple files at a time, not at a time, but individually. So if I did this one, I got my file, I can upload another one. So basically what the user is seeing here is they will see a text file that first shows the parameter names and its equivalence classes, right? So the file I uploaded had 3 parameters: interface edit state, execution type, interface run state. And it also had, each parameter had its own set of equivalence classes, right? So what's going on behind the scenes is, once the file is processed through the API or uploaded, what's going on is it's being passed to a method where it parses the file, and from there it's passed to a method where it creates the combinations. And the way the combinations are listed is just by test cases. So in this file, I know it's the correct amount because there should be 16 total test cases. The way I can figure that out is by multiplying the amount of equivalence classes for the last parameter times the amount of equivalence classes for the second, and then the same for the first one. So it would be 4 times 2 times 2, which would be 4 times 4, which is 16. Right? So as you can see, there's 16 test cases here. So let's go ahead and demonstrate another file. Let's choose a file. Let's do quadratic equation solver. Upload, and as you can see, we got the message: you successfully uploaded quadratic equation solver.json and received quadratic equation solver-combos.txt. So let's go ahead and navigate to our text file. Just download it. And as you can see here, our file had 4 different parameters: discriminant A, B, and C. And you can see all the test cases here are created, right? And there's 192 total combinations. Let's just do the math. 4 times 4 is 16, times 4 is 64, times 3 is 192, right? So it should be 192 total combinations, and once we check again, we can verify that. One thing to note is that the test cases are made on the same index, just so that it's a little bit easier to read for the user. Moving on, we have our team name and our team members listed individually. And we also have this link here. If the user is not from GGC and wants to learn more about our college, they can click on it and it'll bring you to our GGC homepage where they can visit, or they can research anything they want to know about GGC. Next, going back to the top here, we have a little bit about what the category partition method is. We felt it was important to add this solely because the API is about using the category partition method, so a user should be able to see exactly what the category partition method is. Then finally, we have the roles of this team. The code architecture was Puen Shi. The UI and UX design and testing lead was Constance Yang. The team manager and client liaison was Michelle Watson. And documentation lead and data modeler was myself, Cameron Ventimilla. That's basically a demonstration of our API. It doesn't look like a lot, but there's a lot that goes on behind the scenes. It's kind of hidden just from the fact there's only a few buttons and a couple links. But there is a lot that goes on behind the scenes. So going back to our presentation, some of the challenges and lessons learned. Starting off with the challenges, figuring out the algorithm was very difficult. We originally tried solving it recursively, but found that we were at a roadblock for a long period of time. It felt like a few weeks that we were stuck on it. Eventually, we were able to come up with a matrix idea, and we're able to solve it a little bit, probably like 2 weeks ago, right? So it took us a long time to figure out this algorithm. And another problem was working with Spring. We didn't really have any prior knowledge with working with any APIs. So learning and adapting to Spring was a little bit tough at the start. And it got a little bit easier as time grew on with a little bit more research and practice. But it was still a challenge nonetheless. Going to our lessons learned, this first bullet point links directly to the first challenge. Break large problems down into smaller problems. I think we were trying to address the algorithm a little bit too broadly, and we really needed to take time, think about what was going on, and just started just thinking about stuff before we actually tried coding. Because once we actually did that, we were able to solve the algorithm. The next thing is communication is key. We have conflicting schedules, so I don't think we would have been as successful if we were all not communicating the way we were. I think the communication is what led us to actually solving this project, and we weren't able to completely finish the project, but we were able to get majority of it done. I think communication is one of the key things that helped us do that. And then finally, don't underestimate problems. We originally went in and thinking, okay, this project doesn't seem that large. We only have to really create the algorithm and then, create the combinations and do the test case or compare the combination with an expected result, which, in theory, it sounds like it's not a lot, but in actuality, when you start looking at the problem, they become very, very large problems. So I think we went in a little bit too strong-headed, and we underestimated our problems and didn't really manage our time at the start properly. And I think maybe if we did, it might have helped us, solve a little bit more that we wanted to solve. That basically covers my portion of the presentation. I hope you enjoyed. I look forward to see Michelle's presentation that goes over everything related to Jira. Before I end this, let me just return back to this. If what you heard in this presentation was a little bit confusing about these, there's a lot of articles, a lot of demonstrations on Google where you can just research about the Spring MVC, and you can find information about that there. So thank you so much for watching, and I hope to see you guys next time. Thank you.